Alright, we're live. Hello everyone. Welcome back to building a falling sand game in Bevy using Rust. Just to recap where we got to last time, I'll launch the project. Essentially, we just got to the point where we are able to draw sand and have it fall. So that's all good. But there's a few things here. I don't like the color of the sand. And also, did you notice that when we started the application up, we ended up in the menu, first of all, and the game is still running in the background anyway. So let's fix that first of all. So you see we've got this menu plugin, and this comes with this game template that we're using. So if we go into the menu, yeah, it just adds a bit of UI and stuff. But you can also see that there is this game state. So the game is basically run through a game state system, state machine. And it starts off in the loading state. So if we go into the loading state, we can see here, it's just a loading plugin. We're adding the loading state. And so it's basically saying the loading state is the game state loading state. And then after it's finished, it will continue to game state menu. So if we just change this to game state playing, then when the game has finished loading, instead of going to the menu, it'll just go straight through into the game. So let's have a look at that. Now when we run it, it's taking a second for it to start up. Come on. There we go. And you can see it straight into the game now without having to click through the loading. So that's nice for development. We might add a loading state, or we might just go straight into the game, depending. Okay, and now the second thing we want to change is that sand color. So it was kind of almost a green color, wasn't it? Which we don't really want. So I found this nice color palette here, beige sand beach color scheme, and we're probably going to try this sand color. This is the sand color here. So if we have a look in the actual RGB values, it's 218, 194, 159. So I'm just going to copy that, and then we'll go into our falling sand, and then we need to figure out what our actual values are going to be. Oh wow, that is a big calculator. Let's make that a bit bigger, smaller, not bigger. Come on. Alright, there we go, that's a bit more normal. So what have we got? We got 2 and 8 for red, 0.8515, 8515. We got 194 for green, 194 divided by 256, 7578, 7578, and blue will be 159, 6211. Hold on, that's alpha. 0.6211. That was right. Okay. And just save that. I think that's the only place we're using it. Useful to have it defined in a constant there. So let's give that a go. Yes, here we go. We define it in the drawing file, drawing shader as well. So let's just copy that value, go back to drawing, and have it there too. All right. Probably want to put those into a separate include, but that's fine for now. And of course, the color is different. It doesn't look right to me. Is that because we're in a different color space or something? It looks a little bit more like sand. Perhaps we'll go with the darker one. One of these two may be better. We can just reduce it down, can't we, a little bit? So if we do 80, if we do 8, 7, and take 5 off there, so that would be 5, 7. Let's try that instead. Try and run that again. It's kind of okay, but why isn't it falling? Let's have a look. Is it because our epsilon is too small? Yeah, it was. Kind of looks okay. Kind of looks a little bit powdery, a little almost like snow, which is a bit strange considering what these should look like. So, because the 200, for example, 200 is 7, 8. Okay, let's go a little bit darker then, shall we? 7 maybe. 171. Let's go 5, 8 there, which we basically already are. Oh no, 5, 8 in green, and then blue 1, 2, 6. Let's go 4, 5, 4, 4. Alright, Shift F10 to run. Trying to get used to these hotkeys. Okay, and again we're not falling, but it's kind of looking a little bit sandy. Looks a little bit closer to what I would want. Alright, that'll do for now. So let's just tweak the epsilon a little bit. 0.05. I guess we're running into shader precision issues here. Still not enough. 0.1. That seems ridiculously high to me. What? Oh, I tell you what it is. Because I only changed it in one place, right? Not one is probably still fine. Annoyingly having it in 2 places causing problems. Okay. Yeah, that doesn't look too bad. That looks pretty alright, I think. Cool. Okay. So that's the sand color and game state. So now the next thing we want to do is add a size uniform buffer. Alright, so we can actually know how big our canvas size is. Because at the moment, I think we've basically got it as, yeah, here we go. We got simulation size, but we can't vary that. A runtime, it's just kind of fixed, which is okay. But also we have it just hard coded, I believe, in the actual shaders. All right. We're relying on the size of the texture backing, right? So if we look at the texture where we use this, maybe more relevant drawing. Oh, yeah, so you get the texture, and then in order to calculate the size of the canvas, we're just getting the dimensions of the backing texture, which has been okay up to now. But really, we don't want to tie ourselves. You don't want to tie those two things together. All right. We want to be able to have whatever size canvas we want, and then it can just be represented by whatever resolution texture we want as well. So let's go about doing that. So the first thing we want to do is we want to have essentially a way of creating buffers. All right. And a uniform buffer is a blob of data, a bit of data that's available to every invocation of the set of shaders. All right. We're currently using a uniform to pass the texture in, like this handle to the texture. But we want to put in basically our own values, right? So first of all, let's create let's create a method for actually creating buffers. And where do we want to put that? We can just make a new file, I guess. So let's new Rust file, and we'll just call it buffer.rs, and then make sure we actually put it into the module tree. Add it here. Yep. Okay, and so what's this going to look like? We just have a free function, create uniform buffer. And then we want it to have type bindMac pod plus bindMac zeroable. Okay, so just to remind ourselves, plain old data. We just want to set the bits ourselves, basically, and the zeroable marker means that it can be created with zeroed. Okay. So what do we want for the parameters for this? So we're going to need a render device to create it with, right? So let's call that device. Bevy render device. Yeah, all good. The data itself, which is literally just going to be a reference to the type T and a label, optional string. Okay. Oh yeah, and it returns a buffer, which is a Bevy render resource. And then what we do, use the device, create the buffer with the data, and the parameters for this I'll just fill in. Here we go. So first of all, we need the buffer init descriptor. Takes the label, takes the contents. We're going to use bindMac and cast a slice of our own data here, and usage This basically tells us what kind of buffer this is going to be. So we'll have a look at buffer usages, and it's going to be a uniform buffer and a bit flag. Destination. So this means it can be the destination buffer of a copy buffer to buffer, or texture to buffer, or clear buffer, write buffer operations. All right, so that's looking good. That's our create uniform buffer method. Right, and now the next thing we want to do is to actually create some buffers. So we'll head over to lib.rs. Now that we're using buffer, we can just here. Create a struct, call it cellular automata buffers. And this, remember, is going to be our simulation size, so we're just going to call it the size buffer. It's going to be of type buffer. All right. Import that. I think that's in. It's just catching up. Yeah, it's there. Look, buffer. Okay. And then in our setup function, we want to actually create this buffer now. Okay, so alright, so we want to do it after here, I think. So we'll create size buffer. Going to use our actual buffer create method to do that. Filling missing arguments. So we need the device, right? We can just add that to our query by adding it as a parameter to the method. Render device. All right. Okay, so that's the device. And then the data, that's going to be width, height, reference to an array with width and height in it, which are both U32s. And then the actual label. We'll give it a descriptive label just to say simulation size uniform buffer. All right, so that's the buffer created. And we want to insert it into the commands as well. Insert the resource. Cellular automata buffers, and this contains our size buffer. I've named it buffers because we're going to have more than one. Spoiler alert. Okay, that's unnecessary. take that out. Okay. We also need to add the plugin. Let's do that here. Extract resource plugin of type cellular automata buffers. Default. Okay. Right, now we actually want to use this buffer, right? So let's go to our cellular automata pipeline. And now where we create the bind group layout, this is where we're going to use it. So at the moment we've just got one binding for the compute shader stage, and it's a storage texture. Okay, and I've called it texture bind group layout, but we probably don't want to actually call it texture bind group layout anymore, because it's now going to contain other stuff as well. So let's start by just renaming this to bind group layout, not texture bind group layout. Okay, and then right, how we need to change this. I also want to change it there. That's important. And that's my struct. There it is. Could have refactored it properly, but I think that would be okay. And because we're just calling it that now, we can use the shorthand version of struct initialization. That's all good. Okay, so we want our binding 0 to now be our buffer, and then binding 1 is going to be the texture. So let's just change that one to binding 1, and then we create another bind group layout entry, square brackets. Yeah, entries. Can I just do default there just to get it? No, that's okay. So that's going to be our first one, and then our second one is going to be there. Just trying to sort out the actual indentation here. Add missing fields. So yes, binding 0. Visibility, we want it again at the compute shader stage. The type, this is not going to be a texture this time, it's going to be a buffer. Again, fill in the missing fields for that. The type is going to be buffer binding type uniform. Has dynamic offset, we can leave as false, that's fine. And minimum binding size, we want to tell it that this has size, and it is 2 times whatever the size of a U32 is. need to do a bit of casting weirdness. And a bit of weird syntax as well. And I think that is okay. Alright. And that's the end of the array. Alright, so we've now got two bind group layout entries. Binding 0 being our buffer, binding 1 being our storage texture. Okay. And then when we create the bind group, when we queue it, we now also want to add a parameter here to say we've got buffers as well. Of type resource of type cellular automata buffers. Okay, and then in our layout entries, it's not going to be texture bind group layout. And that is now entry 1 because that was the texture. Copy and paste. Let's fix the indentation here. Don't know why there's no space there. And then binding 0 is going to be the buffers, size buffer as entire binding. Returns the binding view of the entire buffer. Okay, making sense. And now we can modify our shader to take the new layout. So let's go to our falling sand shader. And we now can define the fact that we're going to have at binding 1 the texture, oops, but at binding 0, what we had before, this is now our buffer. So it's a uniform. Okay, 2 of type U32. So that's our width and height. And do we actually use it here? I don't think we do we? No, so we've got it available, but we don't actually use it. That's okay, because we definitely do want it in our drawing shader. So let's go through the same process. In the drawing part of our pipeline. So where are our entries? So here we go, we've got the existing entry for the texture. Put that on its own line. Reindent. Okay, so that's the texture binding, which is now at location 1 instead, and then at 0, again we have not a storage texture, but a buffer uniform. Oh no, it's right, buffer. The type being buffer binding type uniform, just like before. Keep that as false. This is just essentially exactly the same as we had in the other part of the pipeline. And it's 2 times texture one's still looking fine. Then when we queue it, let's add the buffers. I love how in Bevy that the queuing the drawing binding group is exactly the same as any other query in the ECS. It's following the very, very similar pattern, which is really nice. So let's do the entries now. We've got that existing entry. Which is now 1. Create a new one, which is 0. It's going to be our size buffer as entire binding. All good. So now we just need to actually modify the drawing shader itself. Very, very similar. The texture is now at binding 1 and at binding 0. We have simulation size, which is a vec2 of type U32. And then where we're getting our texture dimensions, we no longer need to get the size there. And size here can now just be simulation size. as we're passing it through instead. And I think that's the only place we use it. Basically just saying if you're drawing outside of the area, don't do anything. Okay, great. I think that's everything. So let's try and run. Hold on then. Oh yeah, just missed a semicolon. Okay, we probably need to derive some things on our struct. So we need resource, clone and extract resource. Just to make that magically work. Try again. Missing an import, are we? Extract resource plugin. We also want extract resource. Struggled to auto import it there, I think. Okay, a few warnings, but it looks like it's compiling now. Alright, and we're running straight to the game, and something not working. Let me try and just run that again because I kind of fat fingered the window there. Ah, right, okay. We got a WGSL error. Entry point draw at compute is invalid. Bindings for 3. Conflict with other resource. Okay. I've missed something, haven't I? Which one is it saying is invalid? Failed to process shader, line 12. Where are we? Okay. Bindings for 3. Conflict with other. Oh yeah, look what I've done. Tried to bind it to 1. Trying to bind them both to 1. Okay, looking fine. And there we go. Still working. So that's now using the size from the uniform. If we try and draw outside the area, that's basically what that was stopping. But that's all good. We're now using buffers, uniform buffers, to pass in those details. So what we're going to do from here is use buffers for everything other than actually rendering the simulation out at the end. Right? Because at the moment we're using a texture to store the sand and compare the values and everything, whereas it would make much more sense as a buffer, because that way we could just then store the XY values and a U32 of which would just be a number of type. So air would be 0, sand would be 1, stone would be 2, and that way we just need one comparison with a U32 in the buffer, rather than at the moment we're doing this kludge where we're basically doing a vector distance because we are doing the color of the current pixel. and doing all this kind of rubbish to kludge detection of what kind of particle type is in each pixel, in each cell of the simulation, basically. So that'll be something we do next time. We will create buffers for the actual sand particles themselves in the simulation. Replace the texture in the simulation with a buffer, basically. So yeah, thanks for tuning in. That was how to build a falling sand game in Bevy, and I will see you next time.